Hello students, myself Saurabh Kumar and I am teaching physics for JEE Mains and NEET appearance for almost 3 years. Today I am going to discuss law of reflection and especially reflection through the plane mirror. So let us start this topic and let us learn what is the law of reflection and how the reflection through plane mirrors can be possible. Okay, so let us start law of reflection. So basically what is reflection? Before going through the law of reflection, let us see what is reflection. So basically reflection can be carried out from the reflecting surface. Let's say there is a reflecting surface. There can be two types of reflecting surface: polished surface, that is smooth surface, or irregular or diffuse surface. Law of reflection will be only applicable for polished and smooth surface. Okay, that is for spherical mirror and plane mirror. So basically reflection is nothing but when the ray of light incidence, then it will reflect through the reflecting surface in another direction. So this is the incident ray and this is the reflected ray, and there is a normal between them which is perpendicular to the reflecting surface. So this is called normal, this is incident ray and this is reflected ray. Okay, so we can write it as a let's say this is incident ray I, reflected ray R and normal N. Okay, so these three terminologies that we should know before going through the laws of reflection. So first law of reflection tells that when incident ray and incident on a reflecting surface, okay, let's say this is a reflecting surface which is I have taken as plane mirror. Similarly here we can take spherical mirror also. Let's say this is a spherical mirror, okay, which is silvered at the back side of its surface. A glass mirror can be, a plane mirror can be a flat glass which can be silvered at its behind or at the back portion of its surface, then it will become a plane mirror. So when a ray of light incidence at the reflecting surface, it will reflect and the normal. The reflection ray and incident ray and the normal, they will all lie at the same point and they will lie along the same plane. Let me show this with the diagram. Let's say this is a reflecting surface. Let's say this is a reflecting surface and one incident ray is there and it has reflected in this direction. So we can write, and this is, let's say, normal, which is perpendicular to this reflecting surface. So they all will lie along the same plane. Okay, this is the first law of reflection that states that normal angle and incident ray and reflected ray they will be at same point on surface, that is reflecting surface, and along the same line, along the same plane. This is the first law of reflection. Okay, now moving to the second law of reflection. What is second law of reflection? Tells that, let's say, before going through all these things, let us understand some terminologies regarding the law of reflection. So see, this is the angle of incidence and this is normal. So the angle between the incident ray and the normal is known as angle of incidence. Okay, angle between reflected ray and normal is equal to angle of reflection. Okay, so here we can say that, here also I am going, let's say this is incident ray, this is reflected ray, this is normal. Okay, so here it is also angle of incidence and angle of reflection. So in both the cases, I is the angle between I ray, incident ray, and normal. Similarly, R is equal to angle between R and normal. Okay, this is called incident angle of incidence or incident angle. This is reflection angle, reflected angle or angle of reflection. Okay, so second law states that angle of incidence will be equal to angle of reflection. This is the second law of reflection for both spherical surface or plane surface. Okay, that is spherical mirror or plane mirror. Now let us consider plane mirror, reflection through plane mirror. So now let us talk about plane mirror. In the plane mirror, okay, before going through the plane mirror, let us talk more about reflection. What is reflection basically? Okay, see, basically reflection is, let's say this is the surface that I have taken, let's say this is incident ray and this is reflected ray. This is incident ray, this is reflected ray. Now here what we can see, and this is the normal. So here what we can see that the direction of incidence ray is, the direction of incident ray has two components. Let us draw these components. Okay, similarly the direction of reflected ray has also two components. Okay, so here what we can see that during the reflection only that component is changing its direction, which is perpendicular to the reflecting surface. Let's say this is the z axis, this is the x direction. Similarly, this is the z direction and this is the x direction, and let's say this is x, y, z. Okay, so we can clearly see here that the direction of incident ray is changing during the reflection only along the z direction. Okay, but the horizontal component of the incident ray is not changing. Okay, here also we can see the horizontal component is still have a same direction during the reflection. So on the behalf of this we can write that due to reflection the horizontal component of incident ray do not change its direction, Okay, the first thing. And the second thing is only the change occurs along that direction which is perpendicular to the reflecting surface. Okay, occurs along perpendicular to the surface. Okay, so let us talk here that let's say this is I vector, this is r vector. Okay, and if I vector is given as, let's say this I vector is given as a1 I cap plus a2 j cap plus a3 k cap, then what will be the reflected ray in vector form? So the reflected ray can be written in vector form as these two terms will be written as it is, as they are not going to change their direction. Okay, so this will be written as a1 I cap plus a2 j cap. Now this vector, unit vector along z direction, that is going to change its direction. Okay, so it will reverse its direction and it will become a3 k cap. Okay, so this is the required equation for reflected ray in this case. Now let us more discuss about the vector form of reflection in plane mirror, that will study in the plane mirror section. Okay, so let us study the plane mirror, reflection through plane mirror. Okay, so what is plane mirror? It is a flat glass surface which is polished from the front side and it is silvered at the back side so that the reflection can be carried out. Okay, so plane mirror. Now in the plane mirror, let us start talking about the vector form of reflection. Okay, so vector form of reflection in plane mirror. So let us draw one ray diagram for plane mirror. Let's say this is a plane mirror and there is an incident ray which incident on the plane mirror and reflected to this direction. Let's say this is the normal. Okay, now let's say this is the normal, let's say this is the incident ray and this is the reflected ray. Okay, now let us start naming them. This is I, this is I, this is R, this is N. So see, let us say to define the vector form, let us consider one unit vector along incident ray. Let us say it is A cap, one unit vector along reflected ray, that is B cap, and a unit vector along normal, let us say this is N cap. So here we have considered unit vector along incident ray is equal to A cap. Similarly, unit vector along reflected ray is B cap, and unit vector along normal, that is N cap. Okay, so we have to evaluate a relation between A cap and B cap so that we can define the vector form of reflected ray. Okay, so here I am trying to write B cap minus A cap. Okay, what I can write for B cap minus A cap? So see, B cap minus A cap can be also written as B cap plus of minus A cap. Is it correct? Yes. Now what is A cap signifies? A cap signifies the reverse direction of minus A cap signifies the reverse direction of A cap. Let's see here that if this is the plane mirror that we were talking about, or let us draw here. If this is the plane mirror that we were talking about and this is the one ray and this is another ray. Now see here, this direction will indicate the minus A cap, this direction is the B cap, and this direction is normal. Okay, so here what we can see that this is minus A cap, this is B cap, and this is as it is N cap. So this is minus B cap and minus A cap, and this is B cap. So this is B cap plus of minus A cap. It is the nothing but the resultant of these two vectors, which will be the resultant which will be along the normal. So let us find out the resultant between these two vectors. It can be given as V. Let us say this is angle theta, angle of incidence, and this is angle of incidence, and this is angle of reflection. So the component of minus A cap along normal or N cap is given as, and for component of B cap along the normal can be given as mod of B cap cos theta plus mod of minus A cap cos theta, which can be further given as B cap minus A cap is equal to, this will come out cos theta, this will come out cos theta, so adding them 2 cos theta. Okay, now b cap minus a cap is equal to 2 cos theta, where cos theta has to be eliminated. So cos theta, just eliminating cos theta. For eliminating cos theta, what we can do, we can write here, let's say this is equation 1. Now let's say evaluate value of cos theta. So here what we can see, that a cap minus a cap and n cap are aligned with an angle of theta with each other. So what I can say, the dot product of minus a cap and n cap can be given as, since the dot product of minus a cap and n cap can be given as mod of minus a cap into mod of n cap into cos theta. Okay, so the mod of minus a cap and n cap, they will be equal to 1. So the whole product will be comes out as cos theta. So I can write dot product of minus a cap and n cap is equal to cos theta. Let's say this is equation 2. Now substituting this value of equation 2 in equation 1, what we will get, we will get b cap minus of a cap can be given as here what we have written is the magnitude. Okay, so here we have to write the direction also, mention the direction also. So I am applying the direction along which the resultant is, or the component is going. So it is the n cap. So here also I have to mention the direction, okay, that I have followed. Now since b cap minus a cap is equal to 2 into cos theta into n cap, so in place of cos theta just substitute this value. Okay, so 2 into minus a cap dot n cap into n cap, then this minus sign will come out. Okay, then we can rewrite this equation like minus 2 into a cap into n cap into n cap. Okay, so after that let's transferring this a to this side. So b cap can be written as a cap minus 2 into dot product of a cap and n cap into n cap. Okay, this is the required formula for the vector form of reflected ray or the reflection to the plane mirror. Okay, so just let us take one example so that we can easily learn how to apply this formula. Okay, so let me take one example. Let's say incident ray vector I is given as I cap plus j cap minus k cap. Okay, and normal can be given as, or it is given as I cap plus j cap. Now we have to find the vector form of reflected ray. Okay, so simply we have to apply the formula for this evaluation of reflected ray. Okay, so let us write the formula first. B cap is equal to a cap minus 2 into dot product of a cap into n cap into n cap. Okay, so here B is r vector, and a cap is I vector and n cap is normal vector. Okay, so let us start writing the unit vector for a cap, or that is I vector. Okay, so what will be the I cap? So I cap will be the vector form and then the magnitude of this resultant of these three unit vectors. Okay, so what will be the unit vector? I plus j minus k upon under root 3 1 square plus 1 square plus 1 square. Similarly, it can be simply written as I plus I by root 3 plus j by root 3 minus k by root 3. Okay. Similarly, n cap can be written as I plus j upon root 2 1 square plus 1 square. Then it can be also written as I by root 2 plus j by root 2. Now the dot product of a and n we have to find out. So we have to find out the dot product of a and n cap. So the dot product of a and n cap can be easily find out by just multiplying the individual directions, that is x direction with x direction and y direction with y direction. Okay, so magnitude of these two will be multiplied. So 1 by root 3 into 1 by root 2 plus 1 by root 3 into 1 by root 2, that can be equal to 1 by root 6 plus 1 by root 6, that is 2 by root 6. Okay, so now applying all these terms in the formula, so let us find out the r cap can be given as a cap, that is this term, I upon root 3 plus j upon root 3 minus k upon root 3. This is a cap minus of 2 into a dot n, a cap dot n, that is equal to this value. So 2 by root 6. Now after that n cap. What is n cap? Here it is n cap. Okay, so substituting the value of n cap, I upon root 2 plus j cap upon root 2. Now just evaluating all these terms, we can get I by root 3 plus j by root 3 minus k by root 3 minus of, here what we can find out, 2 into 2 is 4 and root 2 into root 6 will be root 12, which is come out 2 root 3. Okay, so 4 upon 2 root 3 can be given as 2 by root 3 I minus 2 by root 3 j. I am multiplying directly with this to this and this to this. Okay, so we will get this type of situation, and then we will find out 2I upon root 3 will be subtracted to this one. So this will come out minus of I cap upon root 3 minus of j cap upon root 3 minus of k cap upon root 3, which can be further written as minus of I plus j plus k upon root 3. This is the value of unit vector along r vector. Okay, that is r cap. Now we have to find out the r vector. So simply r vector can be given as, this is the r vector upon magnitude of r vector. So r vector can be given as minus I cap minus j cap minus k cap. Okay, this is the required answer that we have to find out. Okay, so this is all about the reflection. Okay, and this is the vector form of reflection. Now let us start talking about the formation of image in the plane mirror. Okay, and then we will move to the field of view. So first, image formation. Image formation in plane mirror. Okay, so let us take first a point object. For point object, now how the image will form in a plane mirror and how we have to trace the ray diagram, that we will learn here. Okay, so let us say this is a plane mirror and here it is a point object which is placed in front of mirror. Let's say this is O is the object, this is the point object. Now after that let us start tracing the ray diagram. So first, how the image will form, before that let us start tracing the ray diagram. Let's say this is a ray incident on the surface of mirror. Okay, since the ray incidence with the, when ray is incidence perpendicularly on the plane surface, then the angle between the incident ray and the normal, that will be 0. Okay, so the reflection will also, the angle of reflection will also make 0 degree with the normal. That means it will move as it is by retracing its path. Okay, so this is the incident ray and same will be the reflected ray. Now again tracing another incident ray. Let's say this is another incident ray, let's say this is. Okay, now it will reflect by, according to the law of reflection, it will reflect through it. Okay, so to this. Okay, now yes, in this way it will, this is the, let's say, normal and this is the reflected ray. Similarly here also it is the incident ray and it will reflect to another direction and here it will be the normal. Okay, so how the image will form, that is decided by reflected ray. What we have to do, we have to just simply extend the reflected ray and then the formation of image or location of image will be found out. Okay, so here this will be the location of image. Okay, that we can see here. Like this will be the location of image. Okay, so here image is I, let's say. Okay, so in the plane mirror, the image distance from the mirror and the object distance from the mirror both are same and equal. Okay, so this is x, let's say, so this will also be x. Now here the object is real, here the object is real and this image is behind the mirror and it is virtual. Okay, later we will see there is a virtual object also in a plane mirror. Then we will study the combination of mirrors and image formation in the combination of mirrors. Then we will see the virtual object also. At that time it will be interesting to see how the image will form. Right now we are taking only a single mirror, so there is a one virtual image will form and for a single object. Okay, now let us talk about extended object. Extended object means like a man is standing, like a any object which has a dimension. Okay, so for extended object, so let us talk about the reflection for extended object. Now how we have to define the reflection for extended object? Let us draw the ray diagram for extended object. Let's say this is the plane mirror and let's say this is an object. Okay, now let us name as it O. Now let us trace the ray diagram for this extended object. So how will it form? Let's say this is a one ray which incidents on the plane mirror from the one end of the person or object, and it will similarly reflect back. Second ray, let's say this one is the second ray that is incident on this plane mirror, and if it is a normal then it will reflect along which this direction. Okay, let's say this is incident ray and this is reflected ray. Similarly from bottom also the same, along the same way we can draw the incident ray which will reflects by retracing the path, and let's say this is the another ray which incidents on the plane mirror and reflects by following the law of reflection. Okay, so now just extend all these reflected rays on the plane mirror and we will get the location of the image. Okay, so just extend all these rays which are reflected. Keep in mind we have to extend the reflected ray, okay, to form an image in the plane mirror. Always keep in mind. So this will be the position of the image in the plane mirror. Okay, where we can name, let's say this is I is the image, and now the distance, this distance will also be equal. Let's say this is the distance from image to, this is the object distance from mirror and this is the image distance from mirror. Since both the distance will be equal, this height is also be equal in the case of plane mirror as the object height, which we will learn in magnification. But for knowledge right now we should know that this is height is h0, then this is hi, and hi will be equal to h0. If it is x, the object distance, then image distance will also be x. Okay, similarly after that let us learn about for lateral objects. Okay, now for lateral objects, let's say for lateral objects. So for lateral object the process is same, and see, let's say this is image, mirror, and this is the one lateral object, and this is another, that will be the image of this object. Okay, similarly for lateral object, let's say a lateral object is such as this, then its image will form in this way. Okay, and keep in mind always that this distance will be equal to this distance, and this distance will be equal to this distance. Let's say this is x1, so this will be x1. If this is x2, then this will also be x2. Here also, if it is a and it is b, then it is b and it is a, in case of only plane mirror. Okay, in the spherical mirror this will be different. Okay, so after that let us discuss one question. Let's say one wall is there and a plane mirror is standing on that wall like this. Okay, now let's say this is the origin of coordinate 0 0. Let's say it is O. Now let's say this is 0 3 and this is 4 0. So we have to find out the coordinate of image. Find the coordinate of image. So how we can find out? We can simply apply the geometry and we can find out. Okay, some calculation we have to do. Okay, so how we can find out? So see, the image distance is always equals to the object distance. And how the image distance can be find out? The direct distance or the perpendicular distance of the object from the image, from the mirror, that is equal to the perpendicular distance of the image from the mirror. Okay, so let us trace the perpendicular distance. Let me say this will be the perpendicular distance. Okay, let us call it as a x. So the image will form at the same distance. Okay, this will also be x. So the total distance will be 2x. Okay, so now also we can see this is 4 and this is 3. Okay, so here this is 3 and this is 4. This angle is how much? This angle is 37 and this angle is 53. Okay, so now see, if this angle is 37, then this angle will be how much? This angle will be 53. Okay, so what we have to find out? We have to find out the coordinate. What coordinate we have to? We need this height okay, and this length. Okay, so how we can find out? Let's say this is 53. So in this triangle, this height, let's say y, and this is our x coordinate. Okay, So let us assume this not x. Okay, we will assume it later. So here we have to find the x. Okay, let's say this distance is, let's say this distance is a. Okay, so it will also be a. Now we have to find out x, y, and this angle is 53. Okay, and what we know only this 2a. How to find this 2a? A plus a will be 2a. So let us find first a. A will be equal to how much? And this y can be given as how much? A sine 53, and x can be given as 2a sine 53, 2a cos 53. Okay, so a will be equal to how much? See here, this a. So if this is 4 and this is 37, so a by 4 is equal to sine 37. So here from this triangle what we can learn? A by a upon 4 is equal to sine 37, which is equal to 3 by 5. So it will come out 12 by 5. So a is equal to 12 by 5. So 2a sine 53 degree, y is equal to 2 into 12 by 5 into sine 43, sine 53, 4 by 5. Okay, so here see, a will how much? 4 sine 37 is equal to a by 4. A by 4 is equal to sine 37. So 3 by 5 is equal to sine 37. So it will equal to 12 by 5. This is a. And here 2a is equal to 24 by 5. Okay, so here 24 by 5 into sine 53 degree, which is 4 by 5. So it will equal to how much? 96 by 25. Similarly, x is equal to 2a into cos 53, which is 3 by 5. So 2 into 12 by 5 into 3 by 5, which is how much? 72 by 25. This is the required coordinate of image. Okay, now this is all about the image formation in the plane mirror for point object, extended object, and lateral objects. Okay, after that let us start talking about the minimum height of mirror for which a full image is possible for an object. And before going through the minimum height, let us know about the field of view. Okay, first of all let us know what is field of view, and then we will know about the minimum height of mirror. So field of view. Look, it is basically the space or a region into which if the observer will present, then only in that case he will be able to observe the or see the image. Okay, so basically let us trace the ray diagram so that we will clearly know what is field of view. Let's say this is a mirror. Let's say this is an object placed here. Okay, let's say this is an object placed here. Now let us draw some ray diagrams. Okay, let's say this is first ray incident on this mirror. and reflects to same direction, retracing its path. Let's say this is the second ray, let's say this is the third ray incident. Similarly here also, let's say this is the one and this is two. So they will reflect back according to the law of reflection. Okay. Now see this region into this region, we can clearly see into this region. Okay, all the rays reflecting from the incident incoming from the object and reflecting from the mirror, they are going to up to this region only. Okay, so if any observer will be placed within this region, this space, he will be able to see the image of this object. Okay, so in this case this region is known as field of view. If any observer will be placed at here or here, he will be able to see the image of this object in this mirror. If he will be outside the region of field of view, he will not be able to see the image of this object. Again, let us trace an image. Let's say there is a plane mirror. Okay, and one object is there. Let's say one object is there. Let's say this is O. Then we have to draw the field of view. So one ray will incident at the one end of the mirror and it will reflect in this direction. Another ray will incident on another end of the mirror and it will reflect on that direction. So here also this region will be the field of view. Okay, this region will called as field of view. Means if an observer will be placed here in this region, then only he will be able to see the full image. If he will placed here or anywhere or here also, then he will not be able to see the image of that object. Only at this region the observer will be able to see the image. Okay, this is the, let's say this is the first example, this is the second example. Now let us take another example. Let's say there is a mirror and there is a man standing in front of mirror. Okay, now let's say now what we have to find out, the first we have to trace the ray diagram. So let us trace the ray diagram first. Now what will happen, first incident the ray from the head of the man to the end of the mirror. This is the how to, let us know how to draw the field of view. how to draw the field of view? Basically, trace the incident the ray diagram from the end of the object. I am talking about the extended object. So from the one end of the object to the one end of the mirror, okay, and then from that end to the another end of mirror. Similarly, repeat from the bottom end of the object to the both end of the mirror. See here, from one end of the object I have just incidence one ray at the one end of the mirror. Now the same end of the object I am just doing one incident ray, tracing one incident ray at the another end of the mirror, and then it will go in this way, okay. Similarly, is it from head? Now let us take from leg, okay. There is one end of the mirror and this will be go out like this. Similarly, this will be here and this will go to this way, okay. Now see, let us say that there is observer number 1, observer number 2, observer number 3, observer number 4, 5 and 6 are there, okay. Now how many of them will be able to see the full image, how many of them will be able to see the partial image, and how many of them will not be able to see any image, okay. So that we have to find out. So let us see, let us talk about the 1 and 2, and before talking about 1 and 2, let us define the field of view for this diagram. So what will be the field of view? See, the image of this object will be due to the incident ray from the head and incident ray from the leg. So incident ray from the head is here, incident from the leg is here. So whatever be the field of view, that should be within these two reflected rays, okay. So this region that I am tracing right now, this region would be the field of view, required field of view, okay. Means within this region the observer will be able to see the complete image of the object. Now see, here only 1 and 3 are there which are able to see the full image, okay. So 1 and 3, they will see the full image, okay. Now let us talk about 2 and 3. So what is position of 2? The observer 2 is beyond the reflected ray, or from beyond that the observer 2 is beyond the reflected ray that is coming from head, and within the reflected ray which is coming from toe. So he will not be able to see the head of the person, he will be only able to see the leg of the person, okay, because he is out of the range of that reflected ray which is coming from the head. So 2 will be only, he will see the partial image, that is only leg. Similarly, after 2, here it is 4, okay. Same case for 4, he is beyond that reflected ray which is coming from the toe, and within that reflected ray which is coming from the head. So he will be able to see the head only. Okay. And what about the 5 and 6? They are beyond the field of view for partially also or for fully also, so they will not be able to see any image. Okay, so for 5 and 6 we can write no image. Okay, so basically this is all about the concept of field of view. And let us take one example to solve question if it comes based on field of view. So let us take one example. Let us say there is a straight road this is the third one. Okay, 1 2 and this is the third diagram first. Now let us take one example. Let's say this is a straight road, there is a plane mirror and an object is placed in between of them. Let's say this is the object which is placed at the center of image mirror and road. If a person is walking on the road, along this direction, then and if this is the distance between the object and road and object and mirror, this is same distance, then find out, and the height of mirror is, let's say, h, then we have to find out the length of road up to which the man will see the complete image of the object. Okay, so let's say find length of road up to which man can see the image. Okay, so simply what we have to do in this type of questions, we have to just trace the path. So an incident ray will incident on the one end and also at the other end. Okay, and then it will be reflected to define its field of view, and we have to just find out that length of the field of view. Okay, simply we have to do that thing only. So now let us, okay, this is the incident ray that we are talking about. Now let's say this is reflected to this direction at this place, and here also let's say it is reflected to this direction at this place. So we have to just find out this length. Okay, this will be the length of road for which the observer will be able to see the image. So let's say this is x, or let's say this is y. Okay, let's say this is y. Let's say as the observer is, here also mention that observer is placed at the center, so let's say both are x. Observer is at center of the road and mirror. Okay, so just trace the path of the reflected ray, extend the path of reflected ray at behind the mirror, so that we can get a complete triangle. Okay, also get the image of the object. So here we will get image of the object, and now here we can see there is a triangle. So by the help of similar triangle we can simply apply and find out the value of y. Let's say this is I, this is E, this is F. So triangle A B I is similar to triangle E F I. Just apply that property. So y upon h, this is height of mirror that is given, so y upon h is equal to, this distance will also equal to, this is the image distance, which will also be equal to x. So 3x upon x, which will be equal to, this x will cancel out to each other. This implies y is equal to 3 times of h. Okay, so this is the result that has come out, that it is independent of the position of object. Here we can see it is independent of the position of object, only depends on height of height of mirror. Okay, now after that, this is all about the field of view and one example we have did for this. Now let us know about the minimum height of mirror. Okay, so in the next lecture we will study minimum height of mirror. Thank you for watching.